Thanks a lot. Surprised to see so many people in here, considering that Kenneth Wright is doing a talk downstairs, so I appreciate you guys coming out. So before we jump into things, let me just introduce myself. So my name is Jason Filipe. You can find me on Twitter at jfilipe. I tend to retweet a lot of stuff, so if Twitter's your thing, you can find me there. I work at a startup in Toronto called Wave, more specifically as a developer on the platform team. Wave builds tools to liberate small business owners, like accounting solutions, invoicing, receipt scanning, stuff like that. I know at these conferences there's a lot of entrepreneurs and stuff. You have a lot of side businesses, so if you need any kind of solution, definitely check out Wave. It's free. And what we're going to be talking about today is kind of a deploy process that was initially at Wave and just kind of evolved over time. So what I'm planning on covering is just how a typical deployment process kind of looks like. It's not going to be from ground zero, like we're not going to be manually SSHing into servers and running like git pull. I hope none of you are actually doing that. But as I said before, it's just based off an existing process. And then I'm going to cover the new single artifact deployment process, some of the roadblocks that we encountered, and some of the tools that were used. So for typical deployment is basically a Fabric script. If you're not familiar with Fabric, it's a great Python library that lets you execute local or remote shell commands, so it's perfect for automating deployments. And you would typically just execute something like this. You do fab, set, target, environment, and then the command. So we're just doing a deploy for master, like the head of master. And this is typically run from a developer machine. So the actual details of the Fabric script, so on each app server and worker, they download a tarball of the Git tag from GitHub. They install requirements into a net new virtual env. There's some static asset compilation converting less to CSS, minification and obfuscation of JavaScript. Any database migrations would be run. We would swap the symlinks, both code and virtual env symlinks, and restart the worker processes. If you're not familiar with a symlink-based structure, it's a pretty good practice. So what it looks like on the server is, for the source code at least, let's say that you have all of your releases under /srv/releases/ a timestamp. So then you would have a current symlink pointing to whatever your current deploy, and a previous pointing to the previous, just in case you need to roll back. And then your gunicorn workers kind of only deal with the current symlink in any config files and stuff like that. Same thing for your virtual env. In this case, we have our virtual env in srv/virtual env/default. So that's where your supervisor configs kind of deal with that location only. And same thing, previous is there for rollback. So from the outset, it kind of looks pretty good, right? But there's a few negatives. So I just want to spend a little bit of time talking about like why it sucks, pretty much. So there's the developer machine dependency. So when you execute that initial Fabric script, we're doing that from a local developer machine. So some issues with that is sometimes the office has really spotty internet connectivity. So unless you're doing something fancy with like Screen or tmux and your SSH session times out, you're kind of not in a good spot when database migrations are happening. Additionally, you need some deploy dependencies on the machine. And just in general fear. There was sometimes deploying a certain product worked for one developer, and deploying the same thing on a different developer machine didn't work. So people were always afraid of deploying. Additionally, there was a lot of duplication. So downloading the tarball, installing the requirements, doing all the static asset stuff was not only done on one app server. You have multiple, it's done pretty much everywhere. So it's very wasteful. And worst of all, it was slow. For one of our products, kind of our main product, accounting, it took upwards of 18 minutes to actually do a deploy, and the bulk of that time was just installing the requirements. So we kind of got fed up and we wanted something better. So some colleagues and myself decided that enough was enough. During a hackathon that we had a few months back, we ended up building, we kind of coined single artifact deploys. So the basic idea behind single artifact is just to pretty much create a single tarball that contains the source code, compiled virtual env, and all static assets minified and ready to go. So pretty much all you have to do on the server is just untar the file, swap some symlinks, and then you're good to go. An additional benefit is that so these artifacts are environment agnostic, so you can pretty much take them and deploy them to any environment. So you're guaranteed that whatever you deploy to your testing environment and was signed off on is going to be the exact same thing that's going to go into production. So before we actually dive into the process, I want to talk a little bit about the tools. Both tools used in the build phase to actually create the single artifact and tools that we use to actually serve requests in production. So the first one is HIPCHAT. HIPCHAT is an awesome piece of software. It's basically a software-based load balancer. We use this other little wrapper script called HIPCHAT control that we wrote a little fabric tasks around to kind of take backends in and out of the pool. One thing that I noticed when I was doing these slides is that the one thing that HIPCHAT is missing is actually a good logo. Their current logos are really bad. Next piece is Nginx. Kind of goes without standing. It's our web server of choice. Gets the job done. Simple configs. Can handle a lot of requests, no issues. The next piece is GUnicorn. So this is our WSGI HTTP server. So Nginx ends up proxying the request to our GUnicorn workers. It has really great integration with Django, super simple configs as well, really easy to set up. And as well as Supervisor. So if you're not familiar with Supervisor, it's similar to tools such as like Upstart, Runit, but it's written in Python, so it's awesome. It's also a really cool piece of software. What it does, it just basically manages your processes. So in our case, it's managing our GUnicorn workers. And last but not least, Jenkins. So I mean, CI in this whole kind of process is crucial. If you don't have CI in your current process right now, you're doing it wrong. You don't have to have your own kind of servers tucked under a desk. There's a lot of things such as like Circle CI or Travis, hosted solutions, so that way you can just get tests kind of running. But in our case, we needed to do additional processing, so we also have, in addition to Circle, a Jenkins machine. We use a few plugins as well for Jenkins. This one awesome plugin is called Build Pipelines. So what it lets you do is kind of set up downstream jobs that get executed depending or not if the previous job was successful. So you can build really cool workflows. You can also put in manual human gates. So it could also support something like continuous deployment to a staging server automatically, or even like a push button kind of deploy to production. So when we were starting the actual process, if you've ever dealt with compiled virtual envs, you can run into a few issues. So first off is there's hard-coded paths in the PYC files. So there's tools to mitigate some of these issues, like Fireteam's virtual env tools, which basically iterates through all your PYC files and kind of rewrites the shebang to point to a new path. But unfortunately for us, that wasn't a viable option because we use gevent, and it doesn't actually go through any of the output files, like the compiled output files, to actually change those hard-coded paths. So anything that has any dependencies on C extensions, you're kind of SOL. So the way we got around that was to basically just compile the virtual env in the target directory that's going to be used in production. I'm going to talk a little bit later on about how we do that, but that's pretty much the basis of the idea. So during the build phase, when we're actually creating the artifact, it's pretty much a Jenkins job. This build job is part of our pipeline, and it only gets executed when it passes, or when the previous upstream jobs pass. So we run unit tests, integration tests, and if all that stuff is green, then we actually start building out the artifact. If you haven't seen that build pipeline plugin for Jenkins, this is pretty much kind of how it looks like. This is just a sample screenshot from the plugin page. So each build is a row, and each job is kind of represented as one of these boxes that you can kind of see flow through the system. So this would be like your unit test. If that passed, then it would do the integration, excuse me. And if that passed, then it would start actually building out the artifact. So just a little snippet of what the bash script that we actually have to actually create this looks like is here. So one of the first things that we do is we just take, we just hash the requirements file, and we use that as the name of the virtual env. And that's pretty much like the secret sauce right there. So then we have a directory where we cache kind of all the previously compiled virtual envs. And yeah, so if it's found, we reuse it, we copy it into the workspace. If not, we create it, copy it into the workspace. And then here is, oops. Sorry about that. And then at this point where we deal with the static asset compilation, there's a lot of different techniques that you can use. We use Django compressor and grunt. Don't really have a lot of time to go into that, but it's kind of a messy space. But for us, our artifacts are supposed to be environment agnostic. So one of the issues we had to overcome was Django compressor's manifest file for every environment. So it kind of hard codes your static URL into a JSON file. So what we do to get around that is just iterate through each settings file and just spit out a new manifest for each environment. And then we just ship the, we archive the workspace. So one important thing to note is that your build server must match production, both in like Python version distro, etc. Otherwise, you're pretty much going to have problems. So what you end up with is something like this. So SRV, virtual env, and then just the hash requirements as the name, and then default ends up pointing to that. And now same thing for the release. The only thing that's changed is now we have a virtual env symlink inside the release that points to the actual virtual env. So I'm kind of running out of time, so I'm going to have to start going a little bit faster. So the new Fabric script looks like this. So instead of just saying deploy, you actually can provide an artifact name. So now the new Fabric script on each app server, it downloads the tarball, untars it, lists any migrations. We don't run any migrations anymore. Swap symlinks and restart. So I want to just dive into a little bit on why we now list the migrations instead of running them. Depending on how careful you've been when testing your migration, say in a staging environment, there can be a lot of factors where this could actually blow up in your face. Database or production traffic is very difficult to reproduce on staging, so even database contention can cause additional load on the servers, or on the database rather, and you can have really long running migrations that can essentially take down your site. This is pretty much a talk on its own, so one of my colleagues, Nathan, is actually giving a talk at DjangoCon this year regarding database migration, specifically how you can make your code work pre and post database migrations. So highly recommended, check that out. Another thing I want to talk about is just swapping the symlinks. So when you take an app server out of the pool, it could potentially have active requests still being served. So when you're restarting your workers, there's a few tweaks that you can do to your supervisor settings. So that way it restarts the workers gracefully. Two of those are just the stop signal and the timeout, pretty much. So when you run supervisor control stop and your Gunicorn process name, it'll actually wait until all the requests are finished up until the timeout before actually killing the workers. And then at that point, you can swap the symlinks, bring up the workers, and put it back into the pool. So one thing that's great about this is that it's now really fast. So from 18 minutes, we went down to pretty much 2 minutes. And that's the majority of the time was just waiting for in-flight requests. Another thing that we did was we minimized our single point of failure. So now, if things fail, they only fail during build time. And right now, our only point of failure is GitHub. So when we're actually doing like the checkout. PyPI going down doesn't really matter to us. We run this awesome app called Local Shop that proxies any requests to PyPI to a local server that's hosted internally. What's also nice about Local Shop is that if you have any private packages that you want to host, you can do so there. Or if you don't need all that heavy-handed approach, you can just have just a directory of tarballs of the dependencies. So, sounds good, right? Are we all done? It's much better than the initial deploy process, but we still have that developer machine dependency. But remember, we still have Jenkins. So we can have a job to actually deploy, which is funny enough called accounting deploy. So what that pretty much does is it executes the Fabric script and just runs clean. But you still have to manage the Jenkins credentials, and you do have to click a button, so it's not that cool. We can still do better. At Wave, we use this group chat app called HIPCHAT, and out of GitHub, there's this awesome robot called HuBot, which we coin as Wabot at Wave. So what you can do is actually create small scripts to pretty much just automate your chat rooms. So in addition to, they have a pretty good ecosystem of scripts like converting text into ASCII art or giving you a random picture of like a grumpy cat and stuff like that. But in addition to all those things, now we can deploy all the things. So we can actually deploy from HipChat. So you just say deploy what product, what the artifact name is to what environment, and just give summary, locks the environment, and then just starts the deploy. So pretty much all that Jenkins job does is just execute that Fabric script. We also have other kind of helpers to list out all the artifacts that are available. So there are other alternatives to, I looked at other alternatives to precompiled virtual envs. There's this PEP that was accepted earlier this year called Wheel. It's a new binary package format. And as of like last week, pip released version 1.4 with support to actually build and install wheels. So to build wheels from a requirements file, it's this command. To install them, it's this command. Sorry, I'm going really fast. I have like no time. One thing, like it's awesome because you're not locked into like a strict path for the actual virtual env, but the downside is that it's still slow. On my local machine for the accounting virtual environment, it took around 8.5 minutes, and for us, that's still too long. So some improvements can be made to the existing process. So you can take the single artifact idea one step further and possibly even build native packages, RPM and Debian packages. So that way deploys even become easier. You just do like a yum install accounting, whatever version. A downside to that is you have additional kind of infrastructure to manage, like a yum server and all that kind of stuff. And just some optimizations possibly during the build phase, like using wheels and stuff like that. I'll look at a future possible use case for deploys with tools such as like Docker and Packer. There's this whole idea regarding immutable servers where you can actually kind of freeze dry an entire server, provision a new machine with your code and all the infrastructure, throw that into the pool, and just pull out the old servers. So wrapping up really quick, typically deployments is the longest step installing requirements is the longest step of deploy. Precompile your virtual env in the same directory it's going to be used in production to avoid the hard-coded paths, and enjoy faster deploys. Thanks. So I'm not sure if we have any time for
thank
questions.
you, Jason. Sadly, we have no time for any question. We are out of time. Then maybe you can go
right
on the room
outside,
just in front of the terrace, just there. And yeah.
Great, thank you.
Thank you, Jason.